Okay, panel, we are on live.
Good afternoon, one and all. It's my privilege to introduce today's speaker, Dr. Malayadatta Bora Ma'am. She is working as an assistant professor in the Department of Computer Science and Engineering at the National Institute of Technology, Silchar, Assam. Before joining NIT Silchar, she worked at Assam Engineering College, Government of Assam, Delhi Technological University, Government of Delhi, and she also worked in Indraprastha Engineering College under AKTU. She has received her engineering degree in computer science and engineering from Northeastern Regional Institute of Science and Technology, MHRD, Government of India, and she pursued her Master of Engineering in Computer Technology and Applications from Delhi College of Engineering, Government of Delhi. In Computer Science and Engineering from Delhi Technological University, Government of Delhi. Coming to her achievements, she has authored as well as co-authored around 37 research papers in national as well as international journals as well as conferences. She is actively involved in research works in the field of data mining, blockchains, blockchain technology, cloud computing, ICT, and e-governance. As a result, she has received awards from including Springer. She is the editorial board member of International Journal of Information Systems and Social Change, IGI Global, and reviewer for various journals and international conferences. She is the editor of a multi authored edited book titled Blockchains in Digital Healthcare, CRC Press, Taylor and Francis, which is in progress. She is the associate member of CSI as well as IEEE. It's our pleasure having you, ma'am.
Thank you
Ma'am,
so
over
much,
to you, ma'am.
madam.
Thank you, ma'am.
Thank you so much, madam.
Welcome, ma'am.
Yes,
So we can start the ma'am. We can start the session, ma'am.
yes, sir. Sir, I want to share my screen.
Yeah, please.
Sir, is it visible? Okay, sir. Okay. Respected all the participants. So before starting my today's session, so I want to answer the questions that you have asked in the phone session. So this first question about the scalability issues. Now, when we are talking about the scalability issues, we have come to the workload. Basically, in this blockchain, we can say that that is nothing but the block and the block of size. And similarly, the response time. So, what will be happen here? The challenge should be that we have to anyhow the store all the blocks to the ledger. I mean the full ledger, and that requires the more memory. That is the challenges. Now, for processing it, how will do? Definitely, if we use one solution, that GPU, and for solving, we can solve the complex puzzle for finding the nonce, then definitely we can say, yes, we can do it. The scalability problem we can solve it. Again, you see, in the Bitcoin, there are smart contract like functions are there, like which is known as Latify. And for Ethernet, you can say the one word, the plasma. And we can address these issues with the help of plasma in Ethereum. Now, the second question was about the miner. And question was about how do miners compete for the transaction. Now, your question is that the miner actually competing to find what? The next block and the next block has and the nonce value. Now, sooner the miner find it and he will get the reward. And what will be happen? All the transactions are broadcasted in the network and therefore is not received. It received by the miners. I hope you got my point about the scalability and miner. Now I want to start the session. Now here is the afternoon session. It is based on blockchain history and the architecture. Now this blockchain history, I will start with the evaluation. Then I will go through the architecture part. Then I will give the difference between client-server architecture and blockchain architecture. Then we'll see what is this basically block. We know the block, but what is the basically structure? Then we'll go through the Merkle tree representations and another example of architecture. Now you see here the evolution. I can say that from this branch of technology changes, we can have 4 number of blockchain versions, like blockchain version 1, that is based on the currency, blockchain version 2, that is the smart contracts, and blockchain 3, that is focused on the DApps, and blockchain 4, that is industry standard 4. Let us discuss it one by one. Here, the blockchain 1. We can say that the initial year of 2008 as described for the blockchain version 1. Why? Because I have already mentioned that when Satoshi Nakamoto released his white paper, that is the Bitcoin, a peer-to-peer electronic cash system in the 2008, then you can say that the Bitcoin blockchain technology makes it as a public one. So the starting is the 2008. Now you can see here Bitcoin emergence, and slowly now Bitcoin, I can say that it is one kind of cryptocurrency. Now we have to know what is cryptocurrency here. It means that it's a completely digital formless currency that is tied together using computer science and cryptography and economics. Now question is that why it matters? Because it's purely digital and not controlled by any central entity. Now, according to CoinMarketCap, that is a market of the research website, that more than 2,200 different cryptocurrencies are traded publicly. Now, we can have a look of it. Now you see here the top 5 cryptocurrencies. Like here, the rank 1 is actually the Bitcoin, then the Ethereum. Next, you see, you have asked one questions in the following session that why not in India the finance transactions, primarily basically the banking and all. I told you regarding the trust and all. Just you see here, here is the Bitcoin is what in the USD. Here is US, United Kingdom, United States. Now, similarly, it's a different form that is with Euro, United Kingdom. And the next view you can see here, here is the GBP, that United Kingdoms. And again, you see here the Nigeria they are using. Yes, the Rupee they are using here, United Kingdoms. Yes, these are some of the examples they are using the Bitcoin. Now, let's come to the components of Bitcoin. Here, the 4 primary components are there. Number 1, we can see here the identity management. And second one, transactions. The next one is distributed ledger. And last one is consensus. Now we should know what is basically this. For this case, first we have to check that identity management. Yes, so let us see identity management in context of our daily life. Now, in this case, I can say that I'm sending emails. From my previous examples in the following session, then I can say that yes, I'm having one email ID, and similarly, I can say that I'm having the password for it. And my identity for email that is created by me or created by the institutions. Similarly, in our house, we can say that this is the flat number and this is the particular address. Now, to come to the in context of the currencies. Here, the Bitcoin, you can say there are public keys and private keys. Now, in this case, how to manage? In this case, you see here, I can say that identity, I can receive, yes, I can claim, I can blame something. Yes, fine. Now, how to represent it? Definitely, we are using public and private key. Now, corresponding to the private key, I can say that it acts as to unlock the public key and the money. Similarly, we can say that the private key we can choose at the random and public key is generated from the private key. And the Bitcoin, you can see that it is hidden in the large amount of public keys and to the power of 160 possible addresses. And hence we can say that it is practically impossible for anyone to overlive is using the random generation public key. Now, here is the transactions. Here you can say that for the transactions, what we require? The available funds. Now, again we have to remember that no other transactions using the same funds. Otherwise, there will be problem. Now, here again the distributed ledger already I have explained in the previous section. You see here all the copies are here, the ledger copies are here, and you have asked one question also, the scalability problem. Yes, we have copied all together to all the nodes here. That's why you see here 1, 2, 3, 4 are there. This is a list. Yes, and here is the same, here is the same, here is the same, here is the same. It means that all copies are available, all the nodes. Now, the next one is the consensus. There are 5 parameters are there, that is agreement seeking, collaborative, cooperative, inclusive, and participatory. First of all, we should know what is consensus. It means that it is a dynamic way of reaching the agreement in a group. Now, while we are voting, it settles for a majority rule and without any thought for the feelings and well-being of the majority. And consensus, on the other hand, makes sure that an agreement is reached which could be benefited for entire group as a whole. Now here we should know basically the agreement checking is what it means. It means that it should be about mass agreement from the group as much as possible. That is the agreement. Now, collaborative, it means that it aims to work together to achieve a result that puts the best interest of the group first. This collaborative, I have given the one definition of the blockchain in the earlier session also. Now, the next you can see here the cooperative. It means that all the participants should not put their own interests first and work as a team more than the individual. This means that. Next, you can see inclusive. Now here, as many people as possible should be involved in the consensus processes. The next is participatory. It means that everyone should actively participate in the overall process. Here is also one of the problems you see here. Already you have asked the question scalability. Scalability, yes. You see here, this is one of the problem. That is in 2005, it means that the blocks begin to run out of the space. Here, what will be happen? Definitely, the transactions go unconfirmed. And here the blocks are created in every 10 minutes and can hold only 1 MB of transactions. This is the one of the struggles of the Bitcoin technology. Bitcoin. Now, the second one, that is blockchain 2. It started 2013. and it is what? Based on the smart contracts. Now, here, just you see the smart contract. In this case, like blockchains, which was the name, Satoshi Nakamoto was the name behind the Bitcoin. Now here, the behind the Ethereum development, this blockchain 2 version 2, you can say that Vitalik Buterin is the person who is behind this development. Now, what is the difference we should know between the blockchain? This is version 1 and the version 2 with respect to Bitcoin and Ethereum. Now, the first is just you see here, the first Bitcoin, the aim was the digital currency. Here, it is what? Ethereum, it is the aim is the smart contract. Similarly, the Bitcoin, basically the cryptocurrency, here we see it, the Ether. And the Bitcoin, basically I have already mentioned that SHA-256 hash function they use, hash algorithm. Here is the ethers they use. And I have already mentioned that the struggle of the blockchain in the Bitcoin with respect to, it takes the blocks time, how many? 10 minutes. Here it takes 12 to 14 seconds. So we can say these are the differences. That's why it's come to the blockchain block 2.0 version. Here we should know the smart contract from the figure. What is it basically? It is a small block of programs. Now you can say that the code contains some set of rules which parties that smart contracts agree to enter with each other. It means that the rule is based on some conditions, and this condition is what? The agreement. Agreement for what? The interact with the each other in the group. Now, here smart contract provides the mechanism for efficiently managing tokenized asset and access right between these two or more parties. Now, come to the blockchain 3. Now, it is based on DApp. DApp, we say that it is a decentralized application. Decentralized applications basically avoids the centralized infrastructures, and you can say that DApps have their own backend code running and on a decentralized peer-to-peer network. And you see, DApp can frontend the code. That's why I have written here DApp frontend contracts. And user interfaces written in any languages that can make calls to the backend and like traditional apps. But you just remember, the app can have its foreign hosted on a decentralized storage. That is the main thing. And we can say the Ethereum Swarm, one example we can say here. Now next, come to the blockchain version 4.0. Here, this industry standard 4.0 demands is that we are making the blockchain 3 that is usable in real life business scenario. It means that it can provide solution and a process that make basically blockchain usable form. That is especially in industry 4.0 demands. Now, we can consider some automation, enterprise resource planning, integration of different execution system. Yes. Next, come to the blockchain architecture. Here, I have already mentioned that it is based on P2P network. From this figure, you can identify that yes, it is a P2P network architecture. Here, the core components are the node, transactions, block, chain, miner, and consensus. I have already mentioned in the previous forum session that node means a user or a computer within a blockchain architecture, and it has an independent copy of the whole blockchain ledger. Similarly, I told that transaction is what? It is records or information, and that serves the blockchain as per the purpose of the users. Now, block, I have told you that a data structure used for keeping a set of transactions which is distributed to all the nodes in the network. Similarly, it is a sequence of blocks in a specific order. Now come to the miners, already specific nodes which perform and the block verification process before adding anything to the blockchain structures. Here, the set of rule is nothing but the consensus. Now, we can include here the difference between the client-server architecture and the blockchain architecture. In the client-server architecture, just you remember, I have discussed in the forum session that centralization and decentralizations. Now here, in this case, the client-server architecture, just you can focus on, yes, it is a centralized one. Here, the server is respond to the services which is requested by the client. Similarly, your client may be your any PC, your smartphones, laptop, anything. Here you see the centralized server is used to store the server is responsible basically to store the data. And clients only request and it provides services. In this case, the blockchain architecture, here you can see here, it is a P2P network and Sphere has its own data. And there is no specification or you can say the differentiation between the server and the client. And every node can do both request and respond for the services. Here you see how this blockchain works. Again, the first case, you see here the important transaction. What to do? The transaction is requested. Now, the second is what? Definitely a block that represents the transaction that is created. Here, third is that the block is sent every node in the network. Then the fourth, the nodes validate the transactions. Here, the node received a reward for the proof of work. And the block is added to the existing blockchain. And lastly, you can see that the transaction is complete. Now we come to the block structure. Here you can see that a block is a container data structure that contains a series of transactions. Now, first of all, we should know what is data structure. Data structure is a way of organizing data. Now, with what kind of data structures we can relate with this block? Here, we can say one linear data structure is there, that is linked list. Yes, it is resemblable to the linked list. How? In a linked list, we can say that there are some blocks in the list and they are related through the link, and they consist of the information part, and we can say the next is the next part or the pointer to the next of the block. Now you see here is the same thing. Here I had the block header is there and the list of transactions are attached here with. Now here is the next pointer to the record 1. Then the next pointer, then you see number of n pointers and the representation by the null, the last one. Here you see the pointers. It means what? The next pointer, I told you, next pointer, it means it gives the information about the location of the another variable. It means that it pointing to the position of the another variable here. And similarly, it contains what? It performs, or you can say it forms a linked off list. For example, in the Bitcoin and a block, you can say contain more than 500 transactions on average, and the average size of block is 1 MB, and you can say it may go up to 8 MB, and sometimes it's higher as per the research on defined in 2018. And you see the larger blocks can help in processing the number of transactions in one go. Here you see these two components, the block header, and you see here the list of transactions. Block header 1, block header 2, block header 3, and here is the transactions. Now, the block header, what it contains? It contains the metadata of a block. What is metadata? Metadata means it contains a previous block hash, mining statistics, and constructor block. Now, again it contains the Merkle root. Now this previous, you see, the previous block's hash, there is the previous symbol is there. Yes, we have to attest. Here, the previous hash. It is linked from where? The block header 1. Next, you see here, the block structure. This is the previous block has how to generate. You see here it's of 0. Then The next hash is related to where? From the previous hash. Just to see the example. Here again h of 2 generated from the h of 1, h of 3 generated from the h of 2 and h of 4 generated from the h of 3. That's why it is what? It's linked from what? The previous block of hash. Now this mechanism to generate the hash needs to be complicated enough. Otherwise, what will be happen? Yes, there may be a possibility of what? Possibility of attack. So, to make the blockchain tamper-proof, it should be what? The mechanism to generating the hash. That should be the complicated one. Now, what to do? Define the nonce, the number only once. That the header, the hash value has a certain predefined complexity. And the header contains mining statistics like timestamp, nonce, and the focus on the difficulty level. Here you see the one representation of Merkle tree representation. First of all, I have already said that the root of the Merkle tree is basically the required for what? The verification of all the transactions. Here you see the transactions are there. That is the transactions TA. And it represents what? The TA represents normal transactions. And these transactions are hashed individually to give their corresponding hash value. Now, this hash value is, this transaction is put through a hash function to get corresponding the hash value of H1. Now, in the case of Bitcoin, already mentioned that the hash function, it uses of SHA-256 hash function. And after each transactions, you see there are transactions TA to T of X. After each transactions has been individually hashed to produce the corresponding hash value, the new hash value are combined with an adjacent partner to be hashed once again. For example, here the hash of function h of c from the transaction TC and hash value of from transaction D are combined and has produced to the h of C and G. Now, this example, it contains number of transactions 1, 2, 3, 4, 5, 6, 7, 8. Now, it means that there are 8 transactions and with their own corresponding hash value. However, you see here, if the number of hash value such as 7, you can say odd numbers, then what will be happen here? Now we are pairing because it is 8. 1, 2, 3, 4. In case of, let us say, it consists of the transactions TA to TZ. In this case, what will be happen? Here, the seventh hash is simply paired with itself and has to produce a new value. That is H of S, T of H. This transaction is paired for what? H of H and H of H. Here we'll combine to give of H of H. Now this process is repeated until the last hash value is of T. And the value is known as what? The root. This one, the root of the Merkle tree. And here we can say that this tree structure, generally the root is 32 bytes in size, and we can say that it can be taken place inside a block header, and it represents the summary of all the transactions. Then you can see the previous slides here. The Merkle root, it is placed inside the block, just you see here. Now, what is the advantage of this Merkle tree? Just it shows that it is tamper-proof and it uses the fewer resources and the verifying the transactions. That is the advantages. Now come to the block structures. Here, just you see, yes, the block structures. Before that, just I want to explain what is the meaning basically, the tamper-proof. Here, just to see, we want to basically organizing the transactions. What is the form? The form is the Merkle tree structure. And it becomes very straightforward to verify that the no transactions in the block has been tampered with. Just example, the beforehand. If the transactions in the Merkle tree that we have defined, the last one, the T of H, if it is changed to some T of PQ1, then what will be happen? Yes, the corresponding hash value would be different. Therefore, we can say that when the resulting hash is combined with its adjacent hash partner, it ensuring the hash would be different. And this leads to a completely different Merkle root, and we can say that it is tamper-proof. The next is with respect to the Merkle tree, you see the uses of fewer resources. Here you see the organizing transactions in a Merkle tree structure uses fewer resources than the hash function in one bundle and inserting them into a block of header. Just you see, from the first one, what we have done, the transactions, we have identified the hash value for a particular transactions, then we have combined, and ultimately we are using what? We are using the resources as less as possible. That's why it uses the fewer resources. Now, the next one is the verifying a transaction. Here, This allows for a user to check that the particular transaction has been included in a block or without having downloaded the entire blockchain. It means that it is a query of the blockchain, yes, that the blockchain to check their transactions have been included or not. That is what the verification. Now, for the same example, if I am the user and I want to check the transactions of day, that is after the mapping of h of day that have been included in a particular block or not. Similarly, from the Merkle root, I can visit my previous nodes and I can check it whether this is included or not. So it means that we are verifying the transactions. Now come to this, the block structures. Here, one of the demo versions I have defined from the Undertone with blockchain.com resources. You can also visit there. You can see whatever I have explained, just to see the same thing. Here is the block, the nonce is there and data, and there are some hash value, and there is an option of mine. This is a single block, that's why I have shown here 1. Now come to the next. Here, just to see, there are 2 blocks. It means that it is a blockchain. There are n number of chains, n number of blocks are there which consist of chain. Now, just to see the previous block, what happened here? I'm only defining the block. Here, nothing was mentioned in the previous, in this case. Just you see here, the block seen, here block number 1 and 2. Just the first one, it's previous. Previous is how it is defined, it's 0. Now you compare with the hash value. Here is the hash value, and simply now you connect to the block number of 2. This is block number of 2. Here, what you are finding? Yes, in the block structure itself, we have seen that it is connected with the previous hash value. Now you compare, you see. Now you see here, it's a 0001,578. Now for this block, just you compare here, yes, it is the hash value of the previous block. I hope you understand this much of the hash of previous block as I mentioned in the theory part. Next, you see the same one, but I have put some data here, and apart from this, the hash value, now you can compare with the previous value, that is the block of 1 and block of 2, the hash values are different. That time it was started from 000. Now you see, now you differentiate. It means that in every time the hash value changed. In the Merkle tree also, just I have mentioned that from the transaction of A, we are placing a hash value. I'm getting the h of A. Similarly, I'm pairing from transaction of B, then I'm getting the h of B, then I'm pairing h of A and V. Now, you see the value of nonce also. It is what? Number only once. Now you compare for the first one. It is different. Now here also it is different. It means what? It means that the number is only once will be displayed. Yes, only once. Here you see you can place the mining and you can get the data, no doubt. Just I am placing here JNCC, fine. So I can have some data, more data, but for the practical only purpose, to demo purpose, I have included this data. So I hope you are clear about the hash and this Merkle tree. Now I can again like one of the use cases architecture, but this work is not mine. I have taken from the Wiley, but it's somehow similar to my work. That's why I have taken as an example. And again here, just you see as a use case. For this case, they're using the patient as a user, and the whole system they have divided the hospitals, hospital 1, hospital 2, hospital K, and they're making some private blocks in here. And similarly for hospital data, and they're having one system manager, and it is also associated with the users and the hospitals and the consortium of the block. It means that they are basically making the two types of blockchain. As I have mentioned, we have the three types of blockchain: private, public, and consortium. Here they are making hybrid of what? Blockchain, private, and blockchain of consortium. So this is one of the use cases, and like you see, whatever the implementation purpose, like you can use like programming languages like C, C++, Python, Java, Ruby you can use. Similarly for the, you need the web development also for implementation of the, this kind of like web-based applications and all. So you can use HTML, CSS, Node.js, and the smart contract you can use if you are using the Ethereum, and Solidity for the languages for the Ethereum you can use here. And here some of the implementation platform for the blockchain technology. Just you can see the Bitcoin, already we have discussed, Ethereum we have discussed. And the one question they're asking me, why not for the banks in the Indian? Already I have mentioned because of the trust only, yet to trust. But you see in other section, the like other country, they can use the stroller for the payment. And similarly, Hyperledger is there. That is cross industry. It means that it can be used for the banking, it can be used by the supply chain management, it can be used Internet of Things. Now Oracle also provide the cloud services, and it's a blockchain cloud services. Similarly, the Microsoft Azure, it also provides the cloud computing platform. Similarly, Amazon Web Services, that is Hyperledger, and already mentioned this Ethereum, and IBM Blockchain also they're waiving their like web services, Hyperledgers. Now just to see the benefits you can see, and I think so what can be the benefit for using our blockchain technology in our research work, or in some other cases also. Yes, from the discussion, just you see, it is a trustless exchange, and definitely you can say it's what you can say it's a like durable, yes, then reliable, then you can say yes, longevity, then transparency and immutability. And here just you see trustless means already you have seen that two parties are able to make actually exchange without the like intermediation of the third party. That's why here the translate, and I'm saying this translate, trustless exchange. It means you are eliminating what? The third party. Now, durability, it means that, here, it does not have a central point. It does not have a central point. Then central point of what? Then definitely, it is not a single point one. It's not based on the single point network. So you can say that this blockchain does not have a central point of point of failure. And transparency, it means that it changes public blockchains. It is publicly available to the all parties. And immutability, it means that it cannot be altered. This is the benefit we can say. You can use this blockchain in your research. And also, I hope you can get some fundamentals about the blockchains. And you can see, yes, there are some challenges. And these challenges, these earlier questions about why not in India? Like this is some of the uncertain regulatory status. So we are expecting, we are yet to have, then definitely we will use. Similarly, you see the large energy consumptions. Yes, for mining also you see large energy from the board. Yes, because the copies are distributed to all the nodes. That's why it makes the full ledger. All copies are there. Is definitely the consumption of the energies are large. That's why these are the challenge, and I hope then you got some idea, you have achieved something about blockchain technology. And thank you.
So thank you very much, Professor. So there are, so can you see the comments, please? So there are a couple of questions, you can answer that.
Yes, sir. Comments. Yes, sir. Yes, sir.
There is one question.
Yes, sir.
Professor, there is one question.
Yes, sir.
What are the other ways of storing transactions in the block except Merkle root?
Okay, sir. Now, just I have seen that the Merkle tree we are using for the cryptocurrency. Fine, sir. For the blockchain Merkle tree. Now, in case of block Bitcoin, just example, we can use some blocks like Genesis block and all those things. We are not directly using the Merkle tree. Sir, this is one of the answer.
Okay. So there's one more question. How
Yes,
to
sir.
make blockchain as my career?
Okay, very good. First of all, if you say one thing you can career, first of all, in your higher studies, you can say if you are higher studies in the sense of PhD, or if you are want to do some other things from abroad, yes, you can say you can use as research direction in any field. Any area that include the blockchain technology. And secondly, just you see, like as a minor, if you want to say, if you want to earn something, definitely as a minor you can work.
Hello.
Yes, sir.
What was the software was used in the presentation?
Sir, which one?
What was the presentation? What was the software that was used for the demo presentation? The software
Okay.
what you use, ma'am?
Yes, I have actually just you Google it, you will find it. I have taken one. I'll give the link, sir. You can go to the blockchain information, then you will get it. The details. I will share the details if anyone needs. For the demo one, sir, this blockchain undergroundworld.com, the blockchain. You can refer this, sir. Should I copy paste in the this one or this is undergroundworld.com? That's blockchain, sir.
Okay, okay.
So anyone can Google it. You can find it and you can mine your own blog and you can create some data there. You can insert some transaction. You can mine there, sir. I have highlighted in the, sir, is it visible, sir?
Yes, it is visible.
Okay.
And we have one more question.
Yes, sir.
So, what is a good book to refer for blockchain?
Yes, sir. There are various books of the blockchain technology. I think, sir, you know it better than me. I can say what actually blockchain technology, the advanced blockchain technology. Can I show one? Actually, right now I cannot show. You can use one advanced application of blockchain technology by Sai Hokim and Ganesh Chandra Data from the Springer, sir. And sir,
Yes, yes, please.
yes, you can use also mastering of blockchains
Okay,
by
okay.
Imran. And a reference book, you can use this advances of blockchain applications. And you will find out, sir, some applications which is the Springer publications, and it's a series of studies in big data.
And Professor,
So,
in the introduction, we came to know that you are editing one book in the near.
yes, sir.
Can you throw some light on it, please, so that the participants can contribute the chapter for that book.
Yes, sir, sure, sir, sure, sir. Okay. Sir, should I go through the, what to say, table of content?
Pardon me,
Hello,
ma'am.
sir.
Pardon me.
Should I go through the table of content? I mean, what I'm using here? It
Just
is
brief, ma'am. Just
okay,
briefly, ma'am.
okay,
That's it.
okay. Actually, the first actually chapter, we are technical perspective of the blockchain paradigm. Basically, it will discuss the technical evolution, recent trends and applications of blockchain technology, and it will also focus on technological aspect of blockchain technology and other technology that is closely associated with the blockchain, such as IoT, big data analytics, and digital platforms. And secondly, our next chapter will be based on the genome data management with blockchain technology, sir, in cloud environment. So next chapter, we are proposing healthcare data management using blockchain. Like you can use the electronic health record, monitoring and managing the health record data, care patient and drug traceability. Like it will be covered. Then next chapter, we are focusing on blockchain is pharmaceutical sector, basically the drug discovery and also supply chain management. And next chapter, we are using the managing health insurance using blockchain technology, sir. So the claim adjustment, billing, fraud detection, risk prevention, all those things. And like next chapter, securing same thing like prospect. We are what to say prospect of blockchain in securing healthcare data like smart contracts and all those things. You can highlight. And 7 chapters, it is related to sir IoT and blockchain based healthcare monitoring, basically IoT based. Like again, we have like focused on fraud data detection using IoT and blockchains. And like this way, sir, I forgot it, but
Yes, yes,
These are
no
the
problem.
highlights actually.
Yeah, yeah. Thank you very much. And I think there are no more questions. And
Okay,
participants
sir.
are asking for the PPTs. If it is
Okay,
possible,
definitely, sir. Yes,
please
sir.
share
Sure,
it.
sir.
Yeah, please.
Sir,
And
should I email you? I
yeah,
will
just
email you, sir.
yes, ma'am. Please email it to me. I'll share
Yes, sir.
the I'll share the PPTs all along with other PPTs with the participants.
Yes, sir. Yes, sir. I will do it,
So
sir.
yeah, thank you. I thank you for accepting my invitation with a very short notice, and so delivering beautiful lecture on introduction to blockchain, covering what do you mean by blockchain and the Merkle root, Merkle tree, the block structure, and one application, basically the healthcare application. So of course, it will form a basic for the rest of the sessions. So what we are going to cover in next 4 days. Again, I thank you, ma'am, and hopefully we will get much response for your textbook.
Oh, thank you so much. Just I want to thank you and the organizers of ZNC College and their principals, academics related, dean academics, or head of the department, and head of the department of IT in RITK also, sir, and all the participants, sir. So I think they get some idea. I do not know how much they're receiving from my lecture, but I hope so. They will get the fundamental one. I hope
Yes,
so,
yes,
sir.
yes. They would have got basic idea.
Yes,
So,
sir.
but, so with that basic idea for the next rest of the sessions, probably
Yes,
they'll
sir.
build up more on that one.
Yes, sir.
So
Yes, sir.
thank you very much, ma'am. Thank you very much.
Just, I would like to thank you, sir, giving me the opportunity to be part of this FDP, sir. So
Thank
I want to thank you, all the organizers, sir, including you and from the this organizing college, sir, engineering college, JNCE, sir.
thank you very much.
Okay,
So
thank you,
please,
sir.
ma'am, please stay back. I want to discuss regarding certificate and all. Please stay back. So
Okay,
I'll
sir.
go offline from YouTube. Thank you very much.
Okay, sir. Okay, sir. Sure, sir.